This is my old USB desk fan. It's been sitting in my cabinet gathering dust for several years. I decided to clean it up and see if it was still usable. And as you can see, it's pretty much useless. Now for this device, I had two options. A, to throw it away and buy a new one, or B, try and repair it. And because I'm broke, and my motto is to reduce, reuse, recycle as much as possible, I went for option B and troubleshoot the thing. This could turn out to be just a case of a loose wire or a faulty switch that I can easily replace. If not, I can always salvage the useful parts and repurpose them later for another project. After probing around with every part with my multimeter, I finally found what's causing the trouble. It was this faulty 4-pin Hall effect sensor. This USB fan uses a common brushless DC motor setup, and without this little component, it will simply not run. And because I don't have a spare Hall effect sensor lying around, it was clear this fan will have to be scrapped for parts. But wait, the title says Dead USB Fan Fixed. There has to be some repair action involved, right? And there will be.
There will be.
Now the Hall effect sensor, that's fried, but the rest of the components are perfectly fine. So I decided to look for other ways to run BLDC motors without using Hall effect sensors. I found a couple of videos running BLDC motors using circuits like these. It's a variation of an astable multivibrator circuit, oscillator circuit. This uses a pair of MOSFET transistors to switch motor coils in sequence to spin the rotor. But I didn't have MOSFETs. I do have plenty of salvage BJTs, so I wondered if the circuit would work using regular transistors. It was time for I went ahead and extended the wire leads on the motor coil, and then assembled the components on a breadboard for testing. The circuit wouldn't run the motor in its current form, so I had to experiment with different component values and arrangements until I finally found one that works. The thing wouldn't self-start, but with a little help, it does run with plenty of torque. I'm happy with the amount of air this is moving, so now, on to the next step. First, the parts I used. A pair of C9013 NPN transistors I salvaged from old electronics, two 740 ohm resistors, and two 0.1 microfarad capacitors. Here's the circuit diagram I used. I mounted the components on a piece of 1mm thick cardboard, then soldered the leads in place, then soldered the coil on, wires A and B to the transistor collectors, and the center tap to the positive lead. Now it's time for another test before final assembly. Plug it in, and I went back and checked my connections to see what went wrong. Turns out, I wired the transistors backwards. Lesson here is check, double check, and triple check. After resoldering the transistors in the correct orientation this time, the motor is finally working. It was now time to secure everything to the back cover and reassemble the fan. And that is how I brought my dead USB fan back to life. I really enjoyed working on this project, and I do hope you had fun watching the video as well. Don't forget to subscribe and click the bell icon to get notified on my latest videos. And you might also want to check out my other videos here. Thanks for watching, keep safe, and see you again on my next project.